So good morning. So what we are going to see the Fabino. So today's topic is about the robot motion planning. So in the motion planning, அப்படிங்கிற term வந்து will be used in the robotics for the process of breaking down desired movement tasks, okay, into discrete motions. So which satisfy uh, movement constraints and possibly optimize some aspect of this movement. Okay, so we'll have a motion planning. So motion planning அப்படிங்கிறது பார்த்தோம் அப்படின்னா which is a term which is used in a robotics for the process of breaking down a desired movement tasks into discrete motions that satisfy movement constraints and possibly optimize some aspect of the movement. Okay, how will be having offer? So what is the difference between the motion planning and the path planning? So path planning அப்படிங்கிறது பார்த்தோம் அப்படின்னா so actually it is the process usually we use to construct a path from a starting point to an end point. Okay, so which given a full, partial or dynamic map. Whereas in case of a motion planning வந்து பார்த்தோம் அப்படின்னா it is the process by which we can define the set of actions which need to execute to follow the path that we had planned. Okay, so இதுதான் வந்து path planning and motion planning the difference. Okay, so when you are defining a path planning அது வந்து பார்த்தோம் அப்படின்னா geometric path இருக்கும், we'll have some issues that is by means of an obstacle avoidance and characteristic path இருக்கும். Whereas the case of a trajectory planning வந்து பார்த்தோம் அப்படின்னா we'll have a interpolate or approximate the desired path by a class of polynomial functions இருக்கும். We'll generate a sequence of time-based control set points இருக்கும் for the control of manipulator from the initial configuration towards destinations வரைக்கும் இருக்கும். சரியா? Uh, this is the way we'll have of one robot motion planning. So இப்போ navigation and path planning பார்த்தோம் அப்படின்னா ஸோ global navigations வந்து completely known environmentல இருக்கும், local navigations வந்து with the unknown and partially known environmentல இருக்கும். ஸோ இந்த path planning algorithm வந்து பார்த்தோம் அப்படின்னா for a known environment வந்து is based on classical approaches இருக்கும். ஸோ யூஸ்வலாக என்ன பண்ணுவோம் அப்படின்னா we have to define the task. ஸோ அந்த டாஸ்க்லேருந்து we have to go for the task plan. ஸோ task planலேருந்து we'll be coming for an action plan. ஸோ action planலேருந்து we'll have a path plan. ஸோ path planலேருந்து we'll have a trajectory plan. And finally we'll have a controller. So controller followed by robot and we'll have a sensors. Okay. So sensors will be given to the controllers over on it. Okay. So next time வந்து பார்த்தோம் அப்படின்னா so definition. So we have to define configurations. So this is to be specifications of all the variables that define the system completely. So we have to example go for a configurations of a role. So configuration space on the பார்த்தோம் we'll have a C space. So set of all configurations இருக்கும். Similarly, we'll have a free configurations இருக்கும். That is a configuration that does not collide with the obstacles. Okay. So free spaceல பார்த்தோம் அப்படின்னா set of all free configurations இருக்கும். So it is a subset of C. So when you are going for a path versus trajectory, so path அப்படிங்கிறது பார்த்தோம் அப்படின்னா a sequence of robot configuration in a particular order without regard to the timing of this configurations. This trajectory எடுத்தோம் அப்படின்னா it concerned about when each part of the path must be attained to the specifying the time. So we have to define the path planning for problem definition. So that is we have to compute a collision-free path for a rigid moving object among static obstacles. So input என்னென்ன தேவையா இருக்கும்? We'll be requiring the geometry. How does the robot move? What about the kinematics? And what are all the initial and goal robot configurations? Similarly, output வந்து பார்த்தோம் அப்படின்னா we'll have a continuous sequence of collision-free robot configurations by connecting the initial and goal configurations we'll have over there. So trajectory planning பார்த்தோம் அப்படின்னா there is a while you're defining the problem, we'll have a turn-specified Cartesian space trajectory into an appropriate point positions. So input வந்து we'll have a Cartesian space path and we'll be having the path constraints including velocity and acceleration limits. Output பார்த்தோம் அப்படின்னா a series of joint position or velocity reference values வந்து will be sent to the controller. So this is the block which shows that we have to define the path specifications and we have to define the path constraints for the continuity and smoothness. So we'll have a trajectory planner. With that, we'll be having of a joint space and Cartesian space. So joint space notations will have a Q, Q dot, and Q double dot. So sequence of control set of points will be along the desired trajectory. Whereas in the case of a Cartesian space, we'll have a P, V, and A of T. So joint space versus task space. So joint space பார்த்தோம் அப்படின்னா that is the descriptions of the motions வந்து to be made by the robot by its joint values. Whereas the case of a task space பார்த்தோம்னா the motion between the 2 points is known at all times and it's controllable. Whereas motion between the 2 points in joint space வந்து is not predicted over on it. So it is usually to visualize the trajectory, but it is difficult to ensure singular approaches. So task based planning sequential motions of a robot to follow a straight line, Cartesian space trajectory under the trajectory specified in Cartesian coordinates which force the robot to run it itself. That is the trajectory may require sudden change in the joint angles. So path is not in the workspace. We'll have a start and goal in different solutions and branches. So we have to flip between the configurations. Whereas in case of a trajectory planning, we have two different types of motions, path to point motion, and we'll have